All right, for the video today, we're going to be taking a look at different kinds of relationships, and it kind of carries on from our last Edpuzzle. So the first thing you're going to do is you're going to take a look at these four different relationships, and they're all relating the hours worked and how much money a person earns. So the first thing I want you to do is just to look at those and pick the one out of those four that you think doesn't fit. There's not a right or a wrong answer for this, but you're going to pick one that doesn't fit and then explain in a few sentences why. Okay, so now again, there's no right or wrong answer for this, but when I went through and did it, I did choose one that I felt didn't fit. And the one that I chose was that third one, the one that's highlighted in red. Now, the reason I chose that, because it relates to what we're going to be learning about today in this entire unit, is all three of those that are in blue, right, those are all called a proportional relationship, okay? And that's really what this unit is all about. It's all about proportional relationships. And there's a few terms that you need to know about proportional relationships and what makes something a proportional relationship. We're going to be looking at just tables in this video, but we're also going to be looking at graphs and equations as the unit goes along. So what makes something a proportional relationship when you look at a table? How can you tell? Well, there's two things that you're looking for, okay? One, you're looking for a scale factor, okay, or scaling of ratios. So if you looked at this first example right here, what it means when you scale a ratio, it's when you take a ratio, in this case, the ratios that we are looking at are the hours that you work to the money that you earn, okay? That's my ratio. So if I start with 1 to 15 right there, well, I could take that ratio, and if I was to just double it, okay, so multiply it by 2, the 15 becomes 30, and then the hours worked, I'm also doubling it. Okay, so when you double one of the variables, hours, you're also doubling the money that you earned. And that's true for any of the ratios that you picked, because all of the ratios in a proportional relationship are equivalent. 1 to 15 is the same as 2 to 30. We could also go ahead and, let's look at comparing the second to the third one. So 30 to 150, well, to do that, you multiply by 5. Well, same thing. If you multiply the hours by 5 over here, that's also the same. So that tells you 10 to 150 is going to be the same as 2 to 30, which is the same as 1 to 15. And I could go one step further, okay, and look, well, how do I go from 150 down to 2250, or 10 down to 1.5? That one isn't quite as clear. I'm going to leave it right now, but I will tell you that it is exactly the same, and probably the easiest way to figure that out is rather than going from the 10 and 150 is, let me erase those last two arrows that I just drew, and I'm going to go from the very first one, the 1, all the way down to the bottom one. Okay, and if I want to go 1 to 1.5, what you do is you multiply by 1.5, and 15 to 22.5, I'm not going to work it out right here, but you can trust me that it's also times 1.5. So all of these numbers right here, the times 2, the times 5, the times 1.5, those are called my scale factors, okay? And so the scale factors are what you multiply one ratio by to get an equivalent ratio. Okay? The process, okay, is called scaling. Okay, so this is the verb. Okay, this is the action of multiplying one ratio by another one. Okay, so that's what scale factors are, and a proportional relationship always has scale factors. What about a constant of proportionality? Well, the constant of proportionality is, instead of looking kind of vertically, like scaling a whole ratio, it's when you look at one variable and you compare it, like, how do I go from the variable on the left to the variable on the right? Well, how do I go from 1 to 15? Well, to do that, you multiply by 15. And what about to go from 2 to 30? That's going to be the same. You multiply by 15. To go from 10 to 150, you're multiplying by 15. And on this last one, you can trust me, it's multiplying by 15. So in this problem, that number right there is the constant of proportionality. When we're working with actual variables like hours and money, we do want to attach units to it. So like in this case, the constant of proportionality would equal $15 per 1 hour, or just per hour. That's how much these people are getting paid, okay? So that's what a proportional relationship looks like. As opposed to what it looks like if something's not a proportional relationship. This was the one that I said didn't fit. And you can see on this one, if I'm going like looking for a scale factor, if I go 1 to 2, that's multiplying by 2. Well, what happens on this side? Well, it's not multiplied. If I multiplied by 2, that means this thing would have to be $50, but it's not. So I don't have those, the scale factor isn't the same. And if it's not the same, then that tells me that it's not going to be a proportional relationship. And you can also tell that by looking at the scale factors. So like on this one, how do I go from 1 to 25? Well, you would multiply by 25. Well, what if I chose the last one, 4 to 40? How would I do that? I would have to multiply by 10. You can see those two numbers are not the same. Therefore, there is no constant of proportionality. Constant means that it has to be the same. Okay? And those are not the same, so that's another reason that this is not a proportional relationship. So what I'd like you to do is take a moment. For this problem right here, okay, that second proportional relationship, I'd like you to go through and tell me what is the scale factor that is shown in blue there. Okay? So now on this one, it might not have been so obvious because it's not going to be a whole number. So the scale factor is, if I want to go basically 60 times something, I'll just put a question mark there. Actually, we'll use variables now that we know algebra. I'm going to go 60 times k. Okay, and so 60 times what number is going to be equal to 80? All right, well, that's just a one-step equation. We can solve for k. I'm going to divide both sides by 60, divide by 60, and that's going to give me k equals, that could be simplified to cross out the zeros, and 8 over 6 equals 4/3. So in this case, the scale factor that's being shown, let me erase the k, and I'm just going to change that to 4/3. Okay? And it would change if I had chosen two different ratios to compare, but it's going to be the same on that side. And it might have even been easier if you'd gone to the left side and figured out, okay, what do I have to multiply there? And it kind of works out the same, the equation. Just imagine to go from 6 to 8. It'd be like, let me just take the zeros away. 6 times something equals 8. Well, you'd solve it the same way. You'd divide both sides by 6, and you'd end up with 4/3 as well. And those have to be the same to be a proportional relationship. Okay, in this problem, what's the constant of proportionality? All right, hopefully that one was a little bit easier. Constant of proportionality is just 10, because that's what you're multiplying the first variable by to get to the second one. And because we're working with units here, I would say $10 per hour. All right, so that's how you identify if something's a proportional relationship. We're going to finish this video with 3 different problems. Okay, so question 1. Okay, these are all proportional relationships. Question 1 is this first table. What I would like you to do is go through and find all 3 of the missing values and then add them together. So find this one, and this one, and then add all of those together. Okay, what is the answer? What is the sum of those 3 values? Okay, the correct answer on that one was, hopefully you were able to get that, 850. Okay, so the 3 values, you can see the constant of proportionality here is times 50. And so if I do that for each of them, the first number is 50, the second number is 250, the last number is 550. So those 3 that I circled all end up equaling 850. All right, let's go to question 2. So that'll be the one in the middle here. Same thing. In question 2, you have 3 unknowns. 1, 2, 3. You're going to add all of those together and tell me, what does the sum of those equal? Okay, the answer to this one. And again, how you did this kind of might vary. Let's say that first problem I found the constant of proportionality first. On this one, maybe I use scaling. So I'd say, okay, well, 1/3 times what gives me 1? Well, it's times 3. And so let's do the same thing over here. It's a proportional relationship, so I can do that, which is going to make that a value of 6. And now that you've got that, it's probably pretty easy to see what the constant of proportionality is, right? Like, it's just going to be times 6. So I could use that to get my last 2 unknowns, or you could just keep scaling and say, oh, look, I'm going to multiply by 5. I'm going to multiply that by 5. That's going to give me 30. And using a similar strategy, I could get the last one, which is going to be 540. So if you add all three of those together, that gives you 576. Okay, the last one. This one's probably the trickiest one. So for this one, you're going to go through, same thing. You have three unknowns, 1, 2, 3. You're going to add all of these together, and you're going to find what the sum of that is. I want you to write this as a, your answer is not going to be a whole number. Let's write this as an improper fraction. Okay, so for this one right here, you go through, now how you do this, people do this in different ways. This is how I would approach it. I would probably say, oh look, to go from 1 to 5, I would have to scale this by a factor of 5. So I'm going to do the same thing over here. I'm going to multiply 1.4 times 5. 1.4 times 5 is 7. Okay, so I got one of my three numbers. Now I would probably look and see, okay, let's figure out the scale factor. What is it to go from 7 to 5? Okay, so let me just do a little bit of algebra here. 7 times, sorry, the constant of proportionality. Let's go 7 times c is equal to 5. Well, what is that? Divide both sides by 7. So that value is going to be 5/7. That's my constant of proportionality times 5/7. So that's what I'm going to do to find this next missing value. I'm going to multiply that by 5/7. 1 times 5/7 is 5/7. And then lastly, I'm going to do the same thing on the top. Now, instead of writing 0.2, I'm going to go ahead and turn that to a fraction because I just think it's going to be a little bit easier to work with. So 0.2 is equal to 1/5. So then I'm going to take 1/5 times 5/7. And that works out to be 5 over 35, which simplifies to 1/7. Okay, just I could cancel those out to start with too. So that last value is 1/7. So the last thing is to add the three numbers together. So I'm going to go over to the lower left-hand corner here because I'm out of room. 7 plus 1/7 plus 5/7 is equal to 7 6/7. And I asked for an improper fraction, so the answer to that, 49, is going to be 55/7, which is my final answer.